extend it in a number of different ways, particularly to finish up the computation of cost-effectiveness ratios. If all of you hopefully will have recourse to either the downloaded model or the model that you've been working on from this morning. Either one of them should be fine for the purposes here. Okay, so the first thing that we're going to do is you'll recall that our model as it stands includes calculations of a variety of health economic quantities, including cumulative undiscounted costs, discounted costs, qualities and discounted qualities, as well as life years lived. And what we're going to do, though, is to take into account the fact that there's a certain degree of statistical variability within the result. So if we go down to the randomness area of one of our, let's say, our baseline 50-year, we're going to set so that it's based on a random seed here. Okay, Kurt, could you get in here? I'm going to need some statistics from you.
Okay.
Thanks. So you recorded those values, right?
Yes.
From before? Okay. Ladies and gentlemen, we've gone down to this baseline 50-year and set it to be random seed. Kurt earlier had recorded for us certain values for the outcome of the health economics quantities, particularly qualities and cumulative discounted costs. So, Kurt, can you comment on the values you have for the baseline?
Baseline is 10.7 million.
10.7 million. Okay, so I've just run it again and I've gotten 10.07. Okay, and for qualities, this is baseline. Yeah.
Okay. Do you want me to update that?
No. I'm trying to demonstrate the random variation.
And I got 41.8 thousand qualities.
Okay, and this was 42.163. I'm going to run it again. Again, the baseline. All that's differing is the random seed associated with it. All the assumptions are the same. And we're going to run it here, and we're going to see a total qualities of, and this time it's 41.566 thousand qualities, and in terms of discounted costs, were we doing undiscounted? We're doing discounted, right? It's 11.06. So you can see there's a certain degree of variability between times. So what we're going to do is we're going to set up a parameter variation experiment so that we can observe the results of this model over many realizations. So rather than running it a single time, we're going to run it on an ensemble of realizations. I'm going to set up a new experiment, and this experiment will be called a baseline 50-year, baseline 50-year, and I'm going to say Monte Carlo. So it's actually going to run it many, many times, each time with a different assumption about the random number seed, and it's going to be a parameter variation experiment. Okay? Baseline Monte Carlo. Okay.
Can you comment on why you're using the simulation as opposed to the Monte Carlo simulation for them?
Yes, because Monte Carlo isn't supported outside of the PLE in the PLE.
Oh, right. Okay.
Yeah. I also never use Monte Carlo. I always use parameter variation, but I don't see a real need for Monte Carlo, but it can simplify some tasks slightly. Okay, so I've just added a parameter variation experiment. I don't want you to have to depend on more expensive versions of AnyLogic, and this one's supported in all the versions. So for this, in a parameter variation experiment, rather than running the model a single time, it's going to run it again and again and again. And you can use it either to vary parameter values, or you can use it to examine the impacts of stochastics on model results. And that's going to be our initial use of it. So I'd like you to go and set it in the parameters area of the Monte Carlo, of the parameter variation experiment. I'd like you to set it to freeform. Freeform. It's in the parameters area. It says varied in range versus freeform. Again, I want to emphasize that I added a parameter variation experiment. Okay. 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 Okay, who needs TA help? Okay, ladies and gentlemen. So we've set this to run 10 times. I chose freeform, and by default it said 10. Okay? So now I'd like to show you how this works, and then we're going to set it up to collect information of value to us. So we're going to run this experiment, and this experiment will be a bit of experiments we've run. So we're going to run it, and then we're going to go here and run it from this top upper left. Okay? And you'll notice it's running it several times. This is showing how it's using each of the so-called the processing units that are sometimes called cores on my computer to run the simulation successively. This is showing the activity of one core. This is another one. This one's just started over again. This one's taking a while to complete. So it's running this many, many times over. Okay? Okay. So ladies and gentlemen, this is for the Monte Carlo experiment. But I'd like to draw your attention to the randomness area of the Monte Carlo experiment. Okay? Within this area, we have to choose how we're going to handle randomness. We want to choose random seed here so that each time it runs, it will be different. We won't be merely running the exact same results every time. We'll be having different random number seeds, okay? So that's in the randomness area of the Monte Carlo experiment, okay? Okay, now, we're going to be making use of this, this experiment for several, for two major things. But for now, I'd first like to use it in a simplified fashion, okay? So I would like to use this in a way that we're going to accumulate statistics on the outcomes. So in this experiment, if you double click on it, it should open over here. And I'd like to put in place several mechanisms here, ladies and gentlemen. So in the analysis area, I'd like to drag in two things, two data sets. You could see it here, data sets. I'd like to drag in costs from realizations data set. And I'd like to drag in qualities from realizations data set. Next, I'd like to drag in from statistics, cost statistics, and I'd like to drag in qualities statistics. Okay? Okay, so these are located, I want to emphasize, in the experiment. And the experiment's actually going to run the model several times. It's going to create an instance of main, run it to completion, grab some data from it, destroy it, and run it again, and run it again, and run it again. So the experiment is going to outlive any one run of the model, any one run of main. Okay? And these data sets are going to accumulate the data from those different runs. Okay? Maybe what we'll do, just to align these things, is we'll line them up this way. Okay? Which will sort of help clue in. So the rows have to do with what sort of information. The columns have to do with whether we're calculating statistics or per realization data. In other words, data from each time we run it. Okay, now, ladies and gentlemen, I'd like to go on this to the actions, Java actions area. And I'd like you to be able to place into the you'll notice there's several places that you can put code here. Code to run when the initial experiment is being set up, code to run before each experiment is run, code to run before the simulation, each realization occurs, each given run of main occurs, which is going to occur many, many times during the execution of the experiment, code after each simulation runs, after a given iteration runs, a given sort of run through it. We'll talk a little bit about that later. And then after the experiment. We're going to go to after simulation run, and we're going to put the following. This, which in this case is the experiment, that's the thing that we're in, dot costs from realizations data set. You can autocomplete it. Dot add. And we're going to get the thing to add from the model, from main, ladies and gentlemen. So main is accumulating costs. And you don't have to switch over like this, but I'll just remind you that we have cumulative undiscounted costs in here and cumulative discounted costs, okay? Those are in main. They're stocks. They live in main. So back to what we were creating, you're going to add into this cost data set something that is going to ask main. This is doing it after the simulation main. So main is there. It's just finished the simulation. And we're going to extract from that simulation this information. The way in which we refer to main is hinted by this little light bulb. That light bulb is an indication as some information for you. And it refers to root. Root is referring to a top level agent. That's main. Okay? Almost all models I use, it's called main. So we're going to say root dot cumulative undiscounted costs. Okay? So we've just added those in.
Hey, just
Yes.
for me.
Yeah.
If you put main in there instead of root, would it work?
No.
Okay.
No. Because it turns out that you don't have to call it main. So there's some models where it doesn't call it main. So they, instead of dealing with the vagaries of the naming, they just say always call it root. Refer to it as root. Okay? It's like the root of a tree that's hanging upside down, strangely enough. Okay. Similarly, ladies and gentlemen, we're going to add the same thing in to the cost statistics. Okay? This dot cost statistics dot add, and we're going to add, it's the exact same thing we just did. I'm going to actually go copy it from there. Okay? So I'm going to put a comment, add in costs. Okay? Now we're adding cost outcomes from this realization. You don't have to type that, but I will, in case you open my model. Add in qualities outcomes from this realization. For this, we're going to do this dot qualities from realizations data set dot add, and it's going to be root dot cumulative, and excuse me, it's root dot qualities, I think. Qualities. No, we're doing the undiscounted ones here. Okay, we could do discounted, but I just decided to do undiscounted. And similarly, this dot qualities statistics we're going to do add, and it will be root.qualies too. There we go. There we go. You got qualities? Sorry, I can't hear.
Qualities lived?
Oh yeah, it used to be called qualities lived. I changed it to qualities, but because I thought we didn't have to say qualities lived, but it could. That's fine if that's what it's called. That's fine in your model. Okay, so now we're adding these things in, ladies and gentlemen. We're adding them in. So each time it runs, and it's going to run right now 10 times. Each time it runs, we're going to get different numbers, and those are going to be accumulated. Can we run it? Let's run it. Here we go. Run, and here we go. It's running, and each time it finishes, it's going to be adding it in. Okay. Okay. So here are the costs, and you could see they're varying a little bit. Here are the qualities. Okay. Here are some statistics of them: the mean, the min, the max, the deviation, etc. Okay, ladies and gentlemen, that's good. Suppose that we wanted to put them in a histogram. How do we do that? Yeah, we could bring in a histogram and a histogram data set, and we could do it for costs and we could do it for qualities, and we'd see how those would vary. Okay, so I'm not sure I'll do that because it would take some time. We've already gone over histograms twice now, so I think I'll leave that out because I have bigger fish to fry. Okay. Okay. So this would allow us to run this many times, and fundamentally it would allow us to get out from this model pairs of values. So if we run this out consistently, see there'd be a first one in costs from realizations and a comparable one in qualities that would give the costs and qualities for those different outcomes. They'd be in sort of pairs. Okay, the first realization had this many qualities, and it had this amount of costs associated with it, and that's useful. We could do histograms on top of this, but what I want to do is I want to put in place incremental cost effectiveness calculation. I calculate the gains between a baseline and an intervention. Okay, so this is what we're going to do for this. We are going to add in a new experiment, parameter variation experiment. Unfortunately, this is not something that AnyLogic supports built in. Maybe at some point they will, because we've been encouraging them. And this is going to be called ICER Monte Carlo, Incremental Cost Effectiveness Ratio Monte Carlo. This will be a parameter variation experiment. That's very important. Okay? Okay, and I'd like to set 10 excuse me. I would like to set it to be 2 runs. One is going to be for baseline. One is going to be for the intervention. I'd like it to be random seed. And then finally, and this is very important, I'd like to go down to the replications area. I'd like to use replications. Now, replications are going to allow each of these two, the first for baseline, the second for intervention, each of them to run 10 times themselves. So you're going to be able to have different scenarios, each run 10 times. Or it could be, if you want it could be 100 times. I'm going to make it 10 to allow this to come to completion sooner. Okay? The other thing I'm going to do in here, so what did I change so far? I changed this to be free form. I set it to be 2 runs, baseline and intervention. I set it to use a random number seed. I set it to use replications, namely 10 of them. And finally, for model time, I want it to stop at time 50. Okay, 50 years. Okay, now, you will notice that because this is a parameter variation experiment, it gives us the option of specifying values for each of the what? What are these things? Parameters in main. So we're going to have the value of this parameter be different between the baseline on the one hand and the intervention on the other, right? For the intervention, we want it to change the value of this parameter to accomplish the intervention. It's not the only way interventions can be done, but we're going to use it here. So what we're going to say is, if we're running the baseline, we're going to use 1.0. Otherwise, we're going to use 0.9. And this is the way we do it, ladies and gentlemen. You will notice that we can actually go here, and in the parameters, you can use this thing that says index. You see that little light bulb up there? The light bulb is your friend. The light bulb, it gives you useful information. And here it says use index iteration number. So ladies and gentlemen, we're going to say, and so index 0 will be baseline, index 1 will be intervention. So we're going to say if index equals 0, question mark, then use an intervention coefficient. In other words, if we're dealing with the baseline, use the intervention coefficient 1. Otherwise, use 0.9. In other words, if we're for the if we're dealing with the intervention case, that's what it is. Okay, so this is for this intervention coefficient for becoming overweight. We actually put an expression. What this will mean is it's going to be running 10 baseline runs, and for each of them, this particular parameter will have to value 1. For the 10 intervention runs, replications, it's going to have to value 0.9. Why do I say 10? Because we set the number of replications to be 10. Okay? So that's what it's going to be doing. And now we're in pretty good shape, ladies and gentlemen. Okay, so now we're going to start to fill in some of the details. And we're a lot of the way done here with finishing up this whole example. Okay, so ladies and gentlemen, I would like to add in a new type of data set. It's actually the old type of data set, just used in a new way. And we're going to add it into the experiment that we just created, this ICER experiment. Make sure that that's the one that's selected. I'm going to close these others to avoid confusion. It's the ICER Monte Carlo one. Incremental Cost Effectiveness Ratio, ICER. Okay, so we're going to add in some data sets. Here we go. There we go. Baseline, cost, and qualities. This data set is going to record the cost and qualities for each replication for the baseline. And ladies and gentlemen, let's go see how we do that. For this data set, we're going to set it. And here's the key thing, ladies and gentlemen. Data sets, by default, will allow you to insert a single value, well, insert values. You insert a scalar value, and it tags it with time, if it's a data set in main, or by default it will tag it with the iteration number if the data set lives, as this does, in a parameter variation experiment. But we don't want that. We actually, data sets in general will record pairs. And commonly, if you just leave these things checked, it'll be a pair of a time and a value, or here, an iteration and a value. And instead, we want to insert an actual pair ourselves. So one will be cost, one will be qualities. So we want to uncheck that. Uncheck it indeed. Okay? Ladies and gentlemen. Okay, having done that, we're also going to make sure it does not update automatically. We want to be updating it, not some other process. Okay, do you have that? Got or not?
Yeah.
Got. Okay, so let's copy this down. Boom. Okay, and we're going to now have intervention cost and qualities. Intervention costs and qualities. There we go. Okay, great. Okay, so these are going to be our repositories for the information. Next, ladies and gentlemen, next, we are going to add in and I am looking at my instructions here. I think I am going to, I write these up and then I modify them over time. I'm going to vary them. I'm going to add in another data set, and this is going to be called ICER data set. By the way, these guys should really have been called data set. I mean, by my convention, baseline cost and qualities data set. I feel bad not putting that in because it departs from my naming convention, and it's kind of a nice practice to name it with the name of the type of thing last. So when you see the name, you know what it is. Oh, that's a data set. I don't care about it or whatever. And I'm going to have this called ICER data set, Incremental Cost Effectiveness Ratio. So what's going to happen is that we're going to compute the incremental cost effectiveness ratio for a given replication using these two, and we're going to stick it in here. Right? Dollars per quality gained. And it's going to be put in here. Okay. That's what that is. Okay. Now, now this caused a bit of a kerfluffle in Melbourne, but I'm going to put it in anyway. Okay, CEPlane data set. Okay, this is the cost effectiveness plane data set. Okay, okay, the CEPlane. And I want to uncheck use number of completed iterations. It's unchecked for this one, and this last one, but it was left checked for the ICER data set. So I unchecked it, ladies and gentlemen. Okay. Okay. I think Kurt may be raring to go. Okay. Great. Okay, now we're cooking with gas, okay? Okay, excellent, excellent, excellent. Okay, and now, ladies and gentlemen, our attention will go elsewhere. That's all we need to add in. And you can reuse this structure. If you're doing a cost effectiveness ratio with another model, you could just copy this, stick it into there, and just do a bit of fix-up. Okay? Okay, now, we are going to go, and we are going to select this experiment over here, and we are going to go do something that is going to fill in these Java actions. So after the experiment here, okay. Oh, I'm sorry. I did something. I did something. I forgot one final thing. I'm sorry. Let's go put it in. We want to add a scatter plot, the CEPlane scatter plot. We go to Palette, and we go to Analysis, and we're going to go to Plot, like that, Plot. And we're going to drag it so it's bigger. And this is going to be a nice little scatter plot. We've never done a scatter plot before. This will give you a chance to see it. Scatter plot. It's a plot from the palette, and we put it in the experiment. Ladies and gentlemen, we're going to frob it, okay? So this is going to be called CEPlane scatter plot. That's what its name is going to be. And now we will frob, okay? Okay. So, I just want to make sure. Go to the appearance, and under the appearance, there's a thing that says draw line. I'd like you to uncheck that. Boom. Uncheck it. Okay? So we don't want to see lines connecting the points. Under data update, I'd like you to uncheck update data automatically. Okay? And we're not going to bother putting anything in data because we're going to tell it. Oh, sorry, I'm sorry. I speak incorrectly. For data, guess to what we will point it. You got it. You got it. CEPlane data set. Guess, I think we could say legitimately, Jeff, guess whither we will point it, right? Because it's the dative. Yeah. Okay. So the data set would be CE this. Sorry. The name of it is the cost effectiveness plane. This is the name of this thing, and the data set would be. The data set would be this .CEPlane, okay? CEPlane data set, okay? Okay, I think TA help is needed. Okay, ladies and gentlemen, I'd like you to build your model. It should be a happy camper. Okay, build your model and see if it's a happy camper.
Does it camp happily?
I don't really know the lingo. What's plane mean? Why is it CEPlane?
Oh, it'll be a two-dimensional plane. It's a scatter plot, and so it's they call it the CEPlane because it has two dimensions and it's flat as several quadrants.
That's the standard language for it?
Yeah. I'm just thinking of other cases where we call a two-dimensional scatter plot a plane. A phase plane, or a state space plane. A phase plane, you'll call it.
Yeah.
They normally come from 3D things, though, right? It's like you're taking a segment.
Slice of it.
Yeah, slice of it.
Yeah. I don't.
Or projection or
A
something?
projection. Yeah. It's interesting why it's called that. It just seems to be a term of art they use, and I'm not quite sure why. We talk in other areas about phase plane analysis and so on. So, yeah, you're right. It's sometimes associated with like a slice, but it's not clear to me that it is. Okay, ladies and gentlemen, we're most of the way done here, and I'd like to finish this up so Kurt can spread his wings. Okay, so I'd like to go back. So make sure it builds okay, and I'd like to go back to ICER Monte Carlo. And I'd like to scroll down to the Java Actions area. I know this is a lot of work, but you have to do this once. And again, you could copy this to other models and use it again. Okay, now, ladies and gentlemen, and after simulation run, we're going to actually come back here and fix up one thing. Since you folks are such troopers with autocomplete, I'm not going to force you to type something without autocomplete. That would be betraying your trust. So I was going to have you type it, but we're going to come back to it. But what I will do is have you type this. After simulation run, I'd like you to say trace_ln current iteration is : plus, and then you say this dot get current iteration. Okay, I'll put it up there on the big screen. Does this need a semicolon after it?
Yes.
Yes, it does, because you're telling it print this. print it. Okay? Print this out. Yeah. In general, if you're saying, like, call this, you're, yeah.
Yeah, I've never been a super big fan of that. Because if you're saying x equals y, you're not telling it to do anything.
Yes, you are. You're saying assign to x, like overwrite x. No. Whereas if you're computing a value, you don't have, no, it's a compiler distinction between expressions and statements.
Yeah.
And it's a very clear distinction. One is a side effect and one is just computing a value.
From what I think, like, so when you have a, you're saying color equals something, and
Yeah.
you just sort of like, in the color box, you put the word color,
Yeah.
right? You're not telling it, you're sort of like, it's already sort of, in the text that you don't control, it already has the rest of that statement.
The
So
rest
you're putting
being?
in color equals something. Like body color equals and then the color that you put in.
You mean single equals?
Single equals.
That's
Yeah.
a statement.
No, but you're not typing the single equals. It's when you go and you change it to a dynamic value and you put the parameters.
Oh, I see, yeah.
You don't put the semicolon in there because the semicolon is already in there.
Well, yeah, but it's because you're specifying the value. It just
Right.
needs the value.
Yeah, so that's why what you're saying is it's right. It's just for me, I prefer like if you're writing the whole statement, then you write the whole statement including the semicolon. If you're not writing the whole statement, then it already has a semicolon, so you don't put the semicolon. That's how I think of it.
Yeah, but I mean there are.
We could argue the semantics perhaps at a later time.
Yeah. I mean, I think the distinction is you wanted to be clear about the distinction between an expression, or in other words, a formula, and a command.
Yeah.
Because there's the vast majority, 80% of the time, you only need an expression, so you never need a semicolon for those.
Uh-huh.
It's a very firm rule, and there's good reason for it.
Yeah.
From a parsing perspective.
Yeah, my thought's the same.
Yeah.
It's formulated differently.
Yeah. Okay.
Mine's in cylindrical coordinates and yours is in polar.
Fair enough. Okay.
You forget it, AnyLogic.
That's true.
Usually.
Usually.
Sometimes it doesn't.
I put a semicolon in
Yeah.
in one of those imperatives.
And it didn't stop it.
But the other thing is sometimes it freaks out in a way that's disconcerting for
It's hard to
students.
predict, yeah.
And I mean, it'll plop you down into a most unpleasant circumstance.
Like you double click on the error and it'll take you into the code.
Yeah.
And you didn't write that code, and so how do you? So it's a
It's-
lot.
It's like if you forget it, it's simple, but if you add one where you shouldn't.
That's darn right.
Yeah.
Yeah. Yeah.
One thing about the adding it where you shouldn't, that's particularly.
If unsure, leave off. And see what happens.
Yeah. In the system dynamics stuff, when you're going into the equations, if you put a semicolon in there, AnyLogic barfs. Like it just doesn't know how to handle it because of the way it processes those calculations. So if you get really confusing error messages and you're developing system dynamics stuff, that's one thing to look for. So that's probably a good word of warning, I think.
Yeah. It exhibits dysfunction. Yeah.
It's truculent behavior.
Okay, so ladies and gentlemen, we go to after simulation run, and after you printed this, I'd like you to put the following. If the current iteration equals 1, in other words, if we're running the baseline, then we're going to add it into baseline, the data from it, into baseline data set. We're going to say .add, and we're going to add in the two values read from main. So we're going to suck them out of main and put them into the baseline because we've just run a baseline. Root dot, and this is going to be accumulated. Oh gosh, it's called cumulative undiscounted costs. And by the way, this is okay, fine. Root dot qualies. Boom. Okay. Else. So if we are running the baseline, if we've been dealing with the baseline, we add those two things into the baseline. Otherwise, we add them in to the intervention records. This is just recording what's happened, okay? Okay, ladies and gentlemen, so we can actually copy this just like that, and paste it. Okay? And this would be, probably you want to autocomplete it, intervention, cost, and qualities data set. Boom.
So why is it current iteration is 1 and not 0?
Because it numbers them from 1. I think this is correct. This is a good question. I think it numbers them from 1, but you may be right. It may number them from 0.
If it's labeling, it should be from 0. I'm sure that's what I was told.
Okay, let's go see, because we printed out here. Let's go see. Let's go run it. This isn't a chemistry lab. We're allowed to check to run. Okay, let's go run it and let's see. It maybe start at 0, in which case we'll have to change that to 0. Okay, so it's running it, and now it's here it is, 1 2 1 2 1 2.
That's confusing, man.
You're telling me. So I think the reason is they're using a third-party thing called OpQuest, and OpQuest may have been created by mathematicians. So sorry. So if we are using the baseline, well, suffice it to say, just be glad that I'm giving you this so that you don't have to do it yourself. Okay. Yeah, I probably discovered that a couple years ago and said, oh man. Okay, there we go. And now we have one more thing and then we're done. Okay, one more thing and then we're done. Okay, ladies and gentlemen, go to the palette and we will drag in a function. This function is going to go into the experiment. Note that these things are living in the experiment, and it's called perform ICER calculations. Boom. Okay? And the job of this function is to just do something. It's not to return a value. It's just, it performs some action. Okay, now.
So shouldn't you call this a function?
Sorry?
In line with your naming convention, this should be perform ICER calculations.
Function? Yeah, I wouldn't object to that.
I don't think you do it. Like, you don't do it either. Like,
far be it for me to stand in your way. It's just that we use functions so much.
It's like defining something with double at the end. Do you know what I mean? Like when you create an integer, you could be like age integer. But, I mean, you already know it's an integer. And so this way, the functions are so obvious. They're basically another like another data type almost. And then also when you use them and you use autocomplete, it automatically puts those brackets in, which indicates that it's a function.
So, but I like your I really admire your care, and I think it's really good. It's a somewhat different convention because we write enough functions that I guess we just sort of say we leave it out of the function, but we leave out the function part. But it's an interesting point. I'll have to ponder that. That's food for good thought. Okay, so ladies and gentlemen, this function is going to be a little bit large. It's larger than I'd like, but hopefully it won't be too bad. After all, we are fortified by lunch. Okay? Okay. Here we go. Okay, we're going to loop through each of the realizations. Index realization equals 0. Index realization, you should be able to autocomplete this. Index realization is less than the number that we have recorded in the baseline data set. And then index realization plus plus. This is what we want. Okay?
is index realization a variable, so we actually have to split it?
Yes, we actually just declared it here. That's what this is. Yeah, we just defined it there. Okay, ladies and gentlemen, so we're having a for loop. We're going to go start at 0, and we're going to go successfully increment up to whatever the size is minus 1. So we're going to have whatever the size is, number of different realizations we're doing, from 0, 1, 2. So if there's 3 of them, well, 0, 1, 2. Okay, next. Now I'd like you to build right now. Just build early, build often, and grab a TA if you have any help. Good or not? Double.
What happens after the thing runs off the screen?
Uh-huh.
Can you throw that up in Notepad? It looks like people are just having trouble keeping up with the text that's being typed. Yeah, also a little long.
Okay, yeah, I'll just have to type it without autocorrection then, but that's fine. That's fine. That's how I've done it for most of my life. Incremental costs equals intervention cost and qualities dot get x index realization. Okay, so the first thing is we're going to compute the incremental costs. Okay, so we're going to be computing. How are we going to compute that? Well, it's intervention costs minus baseline costs. Okay, so it's going to be this minus this minus minus baseline. There it is, just like that. So that's the incremental costs, ladies and gentlemen. You know, compute incremental costs, i.e. difference between, you don't have to type what I'm typing now, intervention, I'm just putting a comment, and baseline to let you catch up. Well, and to make it more obvious.
Was this ever returned after equals intervention cost and qualities don't get it?
No, this is just wrapping around in a way that's utterly unhelpful. But the problem is that I want it to kind of show what it is. So it just inserts this thing, but no. The only returns are after these semicolons or after these comments. Okay, here we go. And then there's going to be incremental qualities, which is going to be a similar thing. The only difference between incremental costs and incremental qualities is one is going to be get x and the other is going to be get y. Here we go. There we go. Look at that. Because the y values hold qualities, the x values hold costs. That's why it says cost and qualities. So here we go. There we go. Look at that. I think Kurt's looking. Okay. Compute incremental qualities.
Where did the baseline costs and qualities come from?
So he copied that first statement.
Those are the things. Baseline are these things that we already created. These ones.
The baseline costs and qualities
Oh,
data set.
it should be called data set. Sorry, data set. Sorry,
So that's where the
data set. Yeah.
It is that data set.
It's the data set, yeah. I just renamed it this time because I realized my notes had poor form. You're absolutely right. Okay? And this should be called incremental qualities, like that. And those should be referring to the data sets. Okay.
Is there any way to make the thing that you type in bigger, like on our screen? Like the function body thing, is there any way to make this bigger?
Yes, there is.
Can you make that?
Oh, it gets bigger as you type.
So if I just go like that, and I should make it more.
You'll get into being just FYI, you're going to need to close bracket.
Okay, ladies and gentlemen. And then all we're going to do is we're going to say
Just so you don't forget it.
trace ln. We're going to print those out. Maybe we won't print them out. Maybe I won't bother printing them out. Save us a bit of space. Then I'll say ICER, the incremental cost effectiveness ratio. We're going to say XIDZ. This is going to basically divide one thing by another, except if the denominator is 0, it will use a specified value. So this is going to be incremental costs. We're going to divide this by that. Boom. And if the second one is 0, we're going to have infinity. Okay?
You lost a bracket there, Brent.
Oh, thank you. I don't know how that happened. Yeah.
It was when you pasted.
Oh, thank you. Okay? And then we're going to say ICER collection data set, ICER data set. Shouldn't say collection, should say data set. I'm wondering if I'm setting myself up for a bruising, because I created it as a collection last time. Okay. And then in the final, the final, the final crowning glory, this will be CEPlane data set dot add. Yeah, Kurt knows my habits all too well. Incremental costs, incremental qualities, like that. Okay, that's what it is. Okay, so I will put in a comment here. Now compute the incremental cost effectiveness ratio, making sure to handle the case if the denominator is 0. And now record the. You don't have to type this. This is just for you to see incremental, and for people who download this model to see cost effectiveness ratio in the data set, and then this is add the point this point to the CEPlane. Okay. Now the problem is I may have screwed something up because I've been doing this without auto-completion, but I grew up without auto-completion, so it compiles. Okay.
When you go from the test program, the costs. Well, when you go, like when you're writing a test program, you have to have variable costs.
Right.
You have to have variable.
The qualities.
But you can't combine.
You can't combine the same.
Have an X and Y.
Yeah. So that's X and Y thing. It kind of bundles them together. So, ladies and gentlemen, we're gonna run this thing here, and it should be adding things into the. Oh, we forgot. Sorry, folks. We forgot the key thing. The crowning glory was forgotten. And specifically, we just need to go. This is the thing I promised you I wouldn't abuse you by having you type it without auto-completion. So if you go to this experiment, scroll down now, ladies and gentlemen. Scroll down until you get to after experiment. And we will say this dot perform ICER. There we go. So we have to go to the whole thing and we have to call off to this. I was going to have you type it before, but you wouldn't be able to auto-complete it. And I would have been, would have been abusing your trust because I asked you to please always auto-complete. Okay? Okay, who would like me to show something? It was, yeah. So down near the bottom, after experiment. So at the end of the whole experiment, we're going to go over one by one each of the results and plot them on the CEPlane. That's what the code we just wrote is. And I know that code is ugly, but if you think that's ugly, you should see repass code. But no, this really isn't. So here we go, get the incremental costs, the difference between the costs for the intervention and those for the baseline. We do the same thing for qualities, for the intervention, for the baseline. And then, ladies and gentlemen, we divide by one by the other, and then we add them into the data set, keeping track of the ratios, and finally, we add them into the CEPlane. And now, ladies and gentlemen, I will run this for all times. And I'm going to run it up, and as it's running, we should see the data set being populated here. quite soon we should see a data set that's updated here. I would expect. Okay, now wait a minute.
It happens. It just runs. It runs to the very end.
Runs at the very end.
And then it populates.
Okay, yeah, that's the yeah, of course. It's pretty good at the very end. Yeah. Okay. Yes. Right. Here we go. Ladies and gentlemen, we're okay. Okay, it's got to run 20 times. Why 20? 10 times for each of the baseline and intervention. Okay. So Alan, could
Can you look at your code one more time, please?
can.
There are ways where you can use parameters, but there are ways where you can use parameters so it's baseline.
Yeah. Yeah, and in fact, I mean, here they're both, they only differ in that one parameter value.
Oh, is that right?
Yeah, they only differ in that one, but
they're randomly, but
then there's stochastics within the model.
Yeah.
But there's also ways to draw the parameters from distributions, but to keep them the same between pairs.
Yeah.
So like the baseline and intervention. Yeah. Okay, ladies and gentlemen, so here's our incremental cost effectiveness plane here. What is this suggesting? So I would just note here that it's incremental costs on the x-axis and it's incremental qualities on the y-axis. What is this suggesting? It's costing less and it's saving qualities. Okay, so it's secure, it's gaining qualities. But there is one point where it's actually, so these are cost-saving interventions. And, if you can demonstrate with great confidence an intervention is cost-saving and it has health benefits, that's a great deal, It's a no-brainer. Over here, we're getting into the realm of, well, is it cost-effective? And here, it's an intervention that does cost extra, but okay. Okay, this costs extra, but it actually, in this case, it's essentially negligible savings and actually slightly negative. But these are different results, and you can see because of the stochastics, there is some variability in the results. Now, obviously, we could run this 100 times and populate this further. But that, ladies and gentlemen, is the CEPlane, and here are the data sets of the cost effectiveness ratios. And there, what you see is that most of them are negative. I mean, you have dollars per quality adjusted life year saved, and so most are negative because we save money and we gain quality adjusted life years, so they'll tend to be negative. This one is negative for a different reason, because it cost money and it lost life, and so it's a little bit misleading that that's in there. But you could see some variability in results. So we could obviously run this many times. If we want to run it overnight, we could see a really thick band probably of outcomes. Obviously, this is a very toy model, but it shows. It's no mortality, it's no fertility, it's so on. But it does have lots of basic features that you would use for a real model. So you could copy this basic parameter variation and bring it to a different model and apply it. Okay, that's it. Okay, now, ladies and gentlemen, I need some guidance from the group. So I'm gonna post this model. This is gonna be version 4, and I will stop